Least common denominator. This section is a build-up to addition and subtraction of fractions. This is what you have to have before you add or subtract fractions. However, we have to be able to find what the least common denominator is. Well, I want to back up from that even a little bit more, because the least common denominator actually came from let's make sure my pen works here. Try that again. A least common multiple. All right. And when we start talking about least common multiples, we have to understand a least common multiple. Multiple, there it is. Okay. We have to understand what that is. All right. So, and actually how to find it. So I'm going to find the least common multiple between two numbers. Let's go 6 and 8. Keep them fairly small so we kind of understand the concept. When we're talking the least between 6 and 8, it's got to be a small number. That's why it means least. Common means it has to have some common ground between 6 and 8, or the same. So a small number that is the same between both of them. But they also have to be multiples of these two numbers. Okay, and that's the big word that we're looking for, is they have to be multiples. So there's a couple ways we can go about this, right? We can say multiples of 6, and we can go 6 times 1, and we can just list them. 6 times 2, 6 times 3, 6 times 4, 6 times 5, and there are a plethora of those, right? They go on and on and on. Well, if we do that, we also have to list the multiples of 8. So we're going to list the multiples of 8 as 8 times 1, times 2, times 3, times 4, and times 5. And of course, they go on. Now, this actually gives us what we're looking for. So if I look in this list, now I've got multiples of 6, I've got multiples of 8. What's the common number, the smallest number that they have in common? Well, if I look here, it looks like I have a 24 that is also over in this list. So in this case, the least common multiple in 6 and 8 is actually 24. Now, 24 is not the only common multiple between them. Okay? If worse comes to worse, 6 times 8 is a multiple. That's 8 groups of 6 or 6 groups of 8. They are multiples of each other. But that number is 48, which is a common multiple. It's just not a least common multiple. All right. Now, what I've just shown you is a way to find a least common multiple between two very small numbers. We wouldn't do that if those numbers were large, in the hundreds or into the thousands. Okay. It would take too much time, and occasionally we will get off on our arithmetic. All right. We do better with small numbers. So when I look at these numbers again, we're going to do this a different way. All right, so bear with me here. We're still going to find a least common multiple, right? I'm going to abbreviate this time so you guys don't have to listen to me all that much. Least common multiple, we're still doing it between 6 and 8. Now, here's how this goes. I'm going to break these down. And yes, this is a prime factorization tree. This gives me my numbers represented as prime factors. So I can factor this guy down. I can take a 2 out of it. 2 times 4 is 8. Factor it again because 4 is not prime. And this guy is 2 cubed. So these are the prime factors of 6. It's 2 times 3. 2 cubed is the prime factors of 8 written in exponential form. All right. So when I do a least common multiple, here's what I'm looking for. I'm still looking for the smallest number that both of them share together through multiplication. But how does that work with these two guys? It works this way. I'm going to take my bases. As you can see, I have a base 2 over here. I have the base 2 over there. I don't make 2 base 2s. I just have a base 2. I also see over here I have a base 3. So I'm just going to list my bases. So this is all the bases that I have. Okay, I only write them once. So I have base 2 and a base 3. Then I come back. and take my highest exponent of base 2's. Well, if it doesn't have an exponent, it has a 1, right? Over here I have 3. 3 is higher than 1, so I use 3. I don't put them together, all right? I just use the highest exponent of each base. Over here, this is the 3. What's the highest exponent I have of 3? Well, 1. So if I take a look at this number right here, 2 times 2 times 2 is 8, times 3 is 24. And as you recall from our previous slide, 24 was the number that we had found in our list. All right. So it works out faster that way. And not only that, it works out to where I can tell you 2 times 3 is 6. To get to 24, what did I take times it? It's the missing links. So I'm missing another 2 2's. So if I had 2 2's, I add to 1 2, I get 3 of those 2's. So it would be 6 times 4, because 2 times 2 is 4. 6 times 4 gets me 28. Over here, I've got 2 cubed. I'm missing the 3, which tells us that 8 times 3 gets me 24. And as we progress and we start to add and subtract fractions, you're going to see that that number right there comes in very, very handy. All right. So I want to back up just again and come back to this first slide, because our least common multiple is our least common denominator. When we talk about our denominator, we are just simply talking a fraction. And our denominator tells us that we're looking for a fraction in the bottom half. That's our denominator. Our numerator is in the top, our denominator are numbers in the bottom. So we're kind of evolving from a least common multiple to a least common multiple found in my denominator. And kind of what that looks like, give me another slide here, is we have a fraction. So we get, I don't know, let's go 3/10, right? And we have another fraction. Let's call it 4, I don't know, 11ths. Okay? Now, here again, you can list or you can find the least common multiple between those. You can do the prime factorizations. But in this case, 11's prime. Unless there's a factor of 11 over here in 10, which there is not, then I don't have to break them down. I mean, the smallest number that I'm going to have found in those two guys is going to just be 10 times 11. Now, here again, as you kind of noticed, I didn't pay attention to these two guys up here. Why? Because they're not in my denominator. All I care about is those two guys. So 10 times 11 is 110. That is the first time if you list 10, 20, 30, 40, 50, and you list 11, 22, 33, 44, that they will come into contact with the same number. That is the smallest number in common with both of those, as they are multiples. So this is my least common multiple found in my denominator, or my LCD. All right. So now we're going to come back to that first page, and we're going to make this kind of evolve a little bit, because what we do with it is not necessarily a least common denominator. We will shorten this over and make a common denominator. And now we are getting ready to add fractions. All right. So as we look at a common denominator, give me another page here, a common denominator, right? We are looking at our fractions. I don't know, let's call it 1/6, and let's look at 2/9. All right, so 1/6 and 2/9. When we go to add or subtract these, we have to have a common denominator. Yes, I know we can take 6 times 9 and get 54. That is a common denominator. But as we've looked back here, all of our progression is still least. So hopefully that's rubbed off on us a little bit. So as we look at these guys, we get a common denominator of 18. That is the least common multiple found when we have multiples of 6, multiples of 9. That's the smallest number that share the same number, the smallest same number. However, now we have to go back and say 6 times what gets me 18? Well, that's 3. And most kids can probably finish the statement. What we do to the bottom, we, yes, do to the top. So we got to multiply the top times 3. 3 times 1 is pretty obvious. We get 3/18. We come over here to 2/9. 9 times what? What did we do to the bottom? Well, we took it times 2. We got to take that 2 times the top. And 2 times 2 is 4. Okay. Now, that's finding a common denominator. And now we're in equivalent forms. Meaning, we have now written them with the same denominator, right? The same denominator. All right. So we don't want to reduce that. If we do, it just goes back to 1/6 and 2/9, so we're done. We don't want to do that. Why? Because in the next section, this is going to disappear. If I could make that guy disappear. And this is either going to be an addition or a subtraction. Either or makes that 18 become extremely relevant. So hope this helps you. Practice, practice, practice.